Hey guys, alright, so tonight's lesson is over a new chapter, chapter 7, 7-1, Integer Exponents. So we've all done exponents before, things like 5 squared. We all know 5 squared means 5 times 5. Take the base, and whatever the exponent is, you multiply it times itself that many times, so we get 25. In this lesson, we're throwing in the word integer, which means we're now going to have negative exponents. So we need to figure out how exactly negative exponents work. On this slide right here, I'm going to explain zero exponents and negative exponents. I want you to just try and follow me through this part. If I take 5 to the 5th power right here, that's 5 times 5 times 5 times 5 times 5. We have that 5 times, right? And if you multiply all that out, you get 3,125. 5 to the 4th just simply means 5 4 times. So I'm cutting out one of these 5s. Or another way to look at it is I'm dividing out 5, dividing by 5. Well, 5 to the 4th power is 625. To get 5 to the 3rd power, I'm cutting out one less 5. So I get 5 times 5 times 5, or you take this answer and divide by 5 and get 125. 5 to the 2nd power, you're dividing out one more 5. Take 125, divide by 5, and we get 25. 5 to the 1st power, again, divide your previous answer, 25 by 5. 25 divided by 5, we should get 5. Now if I move down to 5 to the 0, same exact thing. I'm going to take this answer, previous answer 5, I'm going to divide by 5, and I get what? 1. That's very, very important, guys. 5 to the 0 power is 1. Okay? 0 power, you get the answer 1. Now I'm going to take, if I go down from 0, I'm at negative 1. So now my exponent is a negative 1. Well, follow the exact same trend we've been doing. I'm going to divide 1 by 5, and I get, we now have a fraction, 1/5. 1 divided by 5. Now I'm going to take that previous answer, divide by 5, and I'm going to get 1 over 25. Okay, what do you notice? What similarities do you notice here? I notice that my 5 squared and my 5 to the negative 2nd share something in common. My 5 squared is just 25, whereas my 5 to the negative 2, I still have that 25, but now it's in the denominator of my fraction. Let's look at that similarity of the 5 to the 1st power. If I look at 5 to the 1st power, I have 5. 5 to the negative 1st power, you still have that same 5, but now it's in the denominator of your fraction. That leads us to this slide right here. You're going to need to pause this and write this important information down. Zero exponents are if you have any number raised to the 0, you're always going to get 1. That's what we learned right here in this frame of the table. So if I take 3 to the 0 power, I get 1. If I take 123 to the 0 power, I get 1. If I take 1 million to the 0 power, I get 1. Any single thing raised to the 0 power is equal to 1. Very, very important. Negative exponents here, it says a non-zero number raised to a negative exponent is simply 1 divided by that number raised to the opposite exponent. So if it's a negative exponent, it's now going to be a positive exponent. So if I take 3 to the negative 2nd, to make that negative exponent a positive one, I just put it in a fraction. I take 1 on top, and then I divide it by the same exact thing, but with a positive exponent this time. So my 3 to the negative 2nd becomes 3 to the positive 2nd. We know what 3 squared is. 3 squared is 9. So 3 to the negative 2nd is equal to 1/9. 2 to the negative 4th. To make this negative exponent positive, I'm simply going to move it from the numerator of a fraction to the denominator of the fraction, put a 1 on top, and I get 1 over 2 to the 4th, which is 2 times 2 times 2 times 2, which gives me 1/16. Okay, we do not ever want negative exponents in our answers, guys. Just like we always reduce fractions, it's just one of those things you always do. You always simplify negative exponents to be positive exponents. Now note this here at the bottom. This is something you're going to want to write down for sure. 0 to the 0 and 0 raised to a negative power, such as 0 to the negative second, are both going to result in undefined answers. All right? So the only exception to a 0 exponent is when it's 0 raised to a 0, and that gives you undefined because that is division by 0. Division by 0 always leads you to undefined. Let's try a couple. 4 to the negative third. To make this exponent positive, what do? I bring it downstairs. I take it from the numerator upstairs down to the denominator, and it becomes positive now. So I have 1 over 4 to the third, which is 1 over 4 times 4 times 4. Well, that gives me 16. 16 times 4 gives me 64, so I get 1/64. 7 to the 0, oh, we've got that one down now. Anything to the 0 is 1. Caution, this you're going to want to write down. There's a big difference here between negative 3 in parentheses being raised to the negative fourth, and then this one right here, the negative 3 is not in parentheses. I have the opposite of 3 to the negative fourth. Notice that the base 3 is positive in this example, okay? It's negative in this example because the negative is included in the parentheses here. So negative 3 in parentheses to the negative fourth power would be, to make my negative exponent positive, I bring it downstairs. I keep that negative 3 in parentheses though. That part's not changing. But now my 4 is positive as an exponent now because it was brought from upstairs downstairs. Whereas this example right here, my negative is going to just stay out in front. And when I bring my 3 down below, it is not negative. The negative stays in the top with a negative 1, and now I have my 3 raised to the positive fourth because I brought it downstairs. My exponent now becomes positive. This answer is going to be negative 1 over, let's see, 3 times 3 times 3 times 3. That's 9. That's 9. So negative 1 over 81, whereas this would give me a positive 1 over 81. Notice that difference, guys. All right, last one. An expression that contains a negative exponent or a 0 exponent is not simplified. We must simplify it. Only write in positive exponent. So I'm going to rewrite this. Notice how my negative exponent here is in the denominator. To make it positive, we bring it upstairs this time. Since it was negative in the downstairs, I make it positive by bringing it upstairs. My negative 5 is allowed to stay right there because it's not an exponent. So I can have a negative in the numerator as long as it's not an exponent. My k to the negative second becomes k to the positive second up in the numerator. Notice how I do not have a denominator now. All right, let's move on to this last example. A to the 0, I know that that right there gives me 1. A to the 0, anything to the 0 is 1. My b to the negative second, I'm going to make positive by bringing it downstairs. Now my c to the negative third, I'm going to make positive by bringing it upstairs. My d to the sixth is already positive. It stays right where it is. So to simplify my answer, I don't need that 1 really. I'm just going to clean it up a little bit. And there you have it. All right, guys, make sure you have all these examples written down. We'll see you later.